Section 8.2 Exponents and Radicals. Question number 1. In this question, we are asked to evaluate the following expression. The given expression is 3 times 2 to the negative 2 divided by 3 to the negative 2 times 16. What we'll want to do first is to rewrite this expression using all positive exponents. So we can write this expression as 3 times 3 squared divided by 2 squared times 16. And then we have 3 times 9, which is 27 in the numerator, and we have 4 times 16, which is 64 in the denominator. Question number 2. In this question, we are asked to rewrite the given expression with positive exponents. Well, we can begin by multiplying the exponents. So we have x to the negative 2 times negative 2 times y to the 3 times negative 2 divided by 4 to the negative 2. And it becomes x to the 4th times y to the negative 6 divided by 4 to the negative 2. Now we can use our properties of exponents to rewrite this expression as x to the 4th times 4 squared divided by y to the 6th. But here 4 squared is simply 16, so we end up with 16x to the 4th divided by y to the 6th. Question number 3. In this question, we are asked to write 102 in scientific notation. The scientific notation is the form c times 10 to the nth power, where c is some number between 1 and 10, and here n is an integer. So we write 102 as 1.02 times 100, which is 10 squared, and this is the answer. Question number 4. In this question, we are asked to simplify each radical expression. And in order to solve this problem, we want to find the largest perfect square which goes in this and this expressions. Now for part A, we have inside the radical, we have 81, which is 9 squared, and here x to the 4th is the square of x squared, the square of x squared. And then we can combine these two in the exponents to write as 9x squared, the square of which. And then this expression becomes the absolute value of 9x squared, but 9 is a positive number and x squared is a non-negative number, a non-negative expression, so this simplifies to 9x squared. For part B, we have 50y cubed inside the radical. Here 50 is 25 times 2, which is 5 squared times 2, and y cubed is y squared times y. This and these are perfect squares, and 2y is the leftover vector. Then we write the square of 5y times 2y. By the way, in order for this quantity to be well defined, we have this 50y cubed should be non-negative, and then y should be non-negative. So this expression can be rewritten as the absolute value of 5y times the square root of 2y, but 5y is always non-negative. This whole thing becomes 5y times the square root of 2y. Question number 5. In this problem, we are asked to rationalize the denominator of the given expression. In order to rationalize the denominator, we multiply by the conjugate of the denominator, both the numerator and denominator. And the conjugate of the denominator, the square root of 13 minus 2, is the square root of 13 plus 2. So we multiply this fraction by square root of 13 plus 2 divided by square root of 13 plus 2. Essentially, we are multiplying this fraction by 1. And then the numerator becomes 6 times the square root of 13 plus 12, and the denominator becomes the square root of 13 minus the square of this 2. So 13 minus 4. And we end up with 9 in the denominator and 6 times the square root of 13 plus 12 in the numerator. Oh, we can factor out the common factor, which is 3. So we end up with 2 times the square root of 13 plus 4 divided by 3. Thank you.